to that directory. But crash dumps are not actually written to those target locations, those target files at the time of the crash. They go to the paging file, not just any paging file, but the paging file on the boot volume. And if you know Microsoft's terminology, you know that boot and system volumes are two of the terms with the most ridiculous meanings ever defined in the history of computers. And that's saying quite a lot, I think you'll agree with me. Because I don't think you can get any worse than take those terms, think about what they should mean, and then just switch them. And the boot volume then means the volume with the Windows directory, and the system volume, the volume that boot.ini and your other boot files are located on. So it has to be the paging file on the Windows volume. But how is that even protected? The reason that it writes to the file instead of just the target is that to write to a plain old file, it would require the help of the file system driver, the IO manager, storage drivers, and it simply can't rely on those things being stable at the time of a crash. So it checksums components involved with writing a crash dump at the time of a boot. At the time of the crash, it checksums those components again, makes sure that they're intact, and then writes directly to the paging file sectors on disk, bypassing file system drivers and using a small subset of functionality that's provided by disk drivers. The reason that the crash goes to the Windows directory or the Windows volume is that that's the only volume on a Windows system that you can't make a striped volume or a volume set. So means that there's a one-to-one correspondence between a sector on the volume and a sector on disk. There's no mapping that has to take place between those two other than an offset. And so it can safely know, hey, if I know the paging file is in these sectors, occupying these sectors on disk, I can write directly to those sectors. Further, the paging file is one of the only files now that you can't defrag while the system's online. So once it gets its map of where it is, it knows that that's where it's going to stay through the life of that system's current boot. There are cases when you configure this system to generate a crash dump where you actually don't even get one still. For example, because the crash goes to the paging file, paging has to be turned on for the crash dump to get written. The paging file is not initialized until a certain point into the boot process. So if the crash happens early in the boot process, for example, when a boot start driver is initializing and it causes a problem, the system can't write to the paging file. Also, if the crash has corrupted components involved with writing the crash dump, you're not going to get a crash dump. A spontaneous reboot is another type of crash, but it's not so elegant as getting the nice blue screen of death. How many people have seen your system just spontaneously, boom, reboot? And that happens when you have a triple fault on an x86 processor. This processor gives up. It's actually two unhandled exceptions. The processor gives up and says, hey, the operating system's out to lunch. I'm just going to go ahead and reset because there's no point in continuing to fault like this. Another reason is the paging file is too small, and you run the risk of that when you configure your system for kernel memory dump because, like I said, the system can't know ahead of time how big a kernel memory dump is going to be. So if you do configure your systems for kernel memory dump, set a paging file that's large enough to occupy, hold all of physical memory, generate a test dump under kind of normal workload and see how big that kernel dump is, and then you can shrink the paging file if you want to. Finally, not enough free space to extract the dump, or the system hangs. And I'll be talking about how to troubleshoot these kinds of problems, crashes that don't have dumps, a little bit later. At the time of the reboot, the session manager process, one of the first user mode process on the system, initializes paging, determines that there's a crash dump in the paging file, and then marks that area of the paging file as off limits for use. A little bit later, WinLogon, the Windows Interactive Logon Manager, starts up. It looks to see if there's a crash in the paging file, and if there is, spins off a process called SaveDump, whose sole job in life is to read those data from the crash data from the paging file and write it up to the target location you've specified. I'll take questions at the end. If you've crashed Windows XP or Server 2003 system, you know that when you reboot, you get presented a nice dialog that apologizes and tells you that, or asks you to send in the crash information to Microsoft to make Windows better. What's happening is that your crash is being sent to a place called Online Crash Analysis. And you can configure this with group policies or computer properties, an advanced tab, error reporting dialog. This slide also talks a little bit about how you can configure the crash reporting options. But what gets sent to OCA when you actually do send a crash is an XML file that has a description of your system, what version of Windows you're running on, what drivers are configured on your system, as well as a mini-dump file. Hence, you get the mini-dump for free. That mini-dump gets sent up to a server farm. And at that server farm, behind it is a warehouse in Tacoma where there's a bunch of Windows developers that failed the security audits from 2 years ago, kernel mode developers. If they have a security problem, they're sent for a 1-month stint at some point to the OCA warehouse where they've got to analyze crashes. And if you think that's bad, and that's why if you work at Microsoft and an Office mate disappears for a while, that's where they've gone. They can't tell you. And what's worse, if they've been caught with 2 kernel mode security problems and they get another strike against them, they get sent to the warehouse and they've got to analyze the crashes with Notepad, which is extremely difficult. I'm just kidding, of course. There's actually an automated server farm that does the exact same kind of analysis you're going to do, that I'm going to show you how to do. That server farm, that automated analysis that OCA performs, has both an advantage over you and a disadvantage over you doing it. The advantage is, during its analysis, it comes up with a unique signature for the crash called a bucket ID. And it looks in the OCA database, looks it up, that bucket ID, and if there's an entry in the database for that ID, that means that some human has analyzed this type of crash, has figured out what the problem is, and figured out what the resolution could be for you. Like there's a new version of a driver or a hotfix, and you get taken to a page that helps you out. The disadvantage that OCA has is if it does that lookup and there's no entry in the database, then it can't tell you anything. Underneath the hood, the analysis engine almost always comes up with some suspicion. And behind the scenes, OCA is going, I bet it's that video driver right there. I know that guy did it. And then it looks in the database, and there's no entry for this crash, and it goes, oh, you know what? I'm sorry, but here, let me take you and show you what it looks like. It says, oh, I'm sorry, a device driver has caused a crash. Have a nice day. And I've told you that the reason that you get crashes is something gone wrong in your kernel mode, and most crashes are caused by a device driver. So not terribly helpful. The problem that OCA is faced with is that they've got this strong suspicion that this particular driver has caused a problem, but if they threw it up in front of you, guess whose lawyers would be calling who else's lawyers within minutes to complain about their smearing of their good name in front of their customer. So OCA is forced to only tell you about things that some humans actually looked at. Now, no disrespect to Vince or the OCA team, but when XP was released, this OCA thing was new. And I started experiencing these crashes on my system whenever I opened a help authoring tool, opened one of the help files I was working on, and went to a certain page in that help file. Bam. Almost always, I'd get a crash. I was reluctant to send my data into Microsoft because back then there were privacy concerns over Microsoft spying on what you were doing. I guess those concerns are still there today. But at one point, I was just like, you know what? I'll go ahead and send it in and see what's going on. So I send in the crash, and I get taken to this, which tells me, hey, we know who caused the problem. Here's the fix. Sure enough, I'd had an out-of-date driver. I went to that Windows update or that NVIDIA site, downloaded the latest version of the driver, and the problem was gone. I never experienced it again. That was the first time I used OCA. That was also the first time that OCA was successful for me, and unfortunately, it was the last time. So it got me all psyched up, and then now I'm back to manual analysis. So let's talk about some basic concepts now, starting with how you analyze a crash yourself. And you're going to need a tool to analyze that crash. You get your choice here. The package is called the Debugging Tools for Windows package, and you can just go to Microsoft site, search for Debugging Tools for Windows, and you'll be taken to the Debugging Tools for Windows homepage, which has a bunch of information about using it, as well as the download links for both 32-bit and 64-bit systems. Within the debugging tools, there are 2 tools that you can use to analyze crashes. Which one you use depends on whether you like GUIs or not. And I know that there's lots of people still out there that like command prompt interfaces, including kernel developers in Microsoft, who wear their usage of the command prompt as kind of a badge of coolness and serious technical prowess. So if you're one of those people, you're going to want to use KD. If you're more like me that likes having multiple windows and you can switch between and see lots of stuff at the same time, you're going to want to use WinDbg. And that's what I'm going to be using